Hello, this is Mr. Jarrett, and in this video I am going to talk you through the computer modeling presentation for Technical Drawing 1. Okay, so I'm going to put this in a full screen. And computer modeling, which if you are not new to Selinsgrove, you have done in the past, you've done in middle school. Middle school uses SolidWorks, so you've done computer modeling before, so it shouldn't be anything new to you. But computer modeling itself is what we are going to be doing in this class. So before 3D modeling, we did a lot of hand sketching to communicate a message to another person. So my senior year of high school, as a part-time job, I actually worked for a cabinetry maker, somebody who does a lot of woodworking for their clients. And one day we went to somebody's house, and the person wanted a cabinet, like a display cabinet, put in the corner of the room. They wanted kind of a pillar up top. They wanted some lights and crown molding around the top, and a walkway into in the next room. So I actually had the pleasure of drawing this. So this is my drawing. I personally don't think it's anything spectacular. It does get you the message across. But the cool thing with this is this communicated that message based off of just little simple lines. And that's what all of this is. Just straight rectangular lines. I simply put a ruler down and I just kind of traced over the ruler over and over and over and over. And of course, this isn't my first drawing that I did. I had to critique it a whole bunch of times. But we were able to take this drawing back to the client, the person who wanted this, and show that to them. And what happened from there was they made some changes. They said, hey, you know what? I want adjustable shelving over here. I want shelving that can go up and down. So as you see, I just kind of drew straight across shelving. They wanted it to be up and down, movable. So, okay, no big problem. Down here, they didn't want cabinets like this. They wanted drawers. So I had cabinets. They wanted drawers. No big deal. But you can see from this picture and a lot of talking from our first meeting, we were able to communicate a message. Now, SolidWorks itself does that same thing, and it does it way better than hand sketching. So SolidWorks is called a CAD program. CAD stands for Computer Aided Design or Computer Aided Drafting. Okay, so this is a software that uses a three-dimensional environment. So a 3D. Okay, so it also has what's called a Cartesian coordinate system. That is a big long phrase there, but to break that down, it's a numeric grid. Okay, it's a numeric grid that commonly is labeled as X, Y, and Z. I'm sure you've seen that by now in math class, X, Y, and Z. Okay, X is left and right, Y is up and down, Z is forward and backwards. So then you have an axis or axes. These are an imaginary line that a geometric object either rotates around or moves along. So if you think about what the Earth does, it rotates around an axis. Okay. Same thing with the moon. The moon rotates around the axis of the Earth. The Earth itself rotates around the sun. So it's an imaginary line. Okay. You also have imaginary planes. So these are flat surfaces on which a straight line joined at any 2 points would wholly lie. That is a definition taken right from the internet. Basically, it's an imaginary flat surface that you can sketch on. Okay, so here's some examples for you. The XY, the XZ, and the YZ. So that still might be confusing for you. It gets a little bit better when you start to see some pictures. So where all of these axes actually cross, you have your 0, 0, 0 point. That's your dead center, and that is called your origin. Okay, origin. All right. So here's a picture you're probably familiar with if you are not new to SolidWorks. These are your planes. This is your front plane, your right side plane, and your top plane. So all of these planes are flat 2D surfaces that you can sketch on. Where they cross is your origin. And if you kind of look at these yellow lines right here are those axes. Okay, so the dead center, the origin, is your 0, 0, 0. Now it says in the Cartesian coordinate system, all 3D objects show height, width, and depth. You might call them something else, but I have been kind of educated to call them height, width, and depth. Okay, so height is from bottom to top, width is left to right, and depth is front to back. So if you kind of think about looking at a person, from the bottom of their feet to their head is their height, from the outside of their shoulder to the other shoulder is their width, and from maybe the front of their body, so maybe their nose, to the back of them, so maybe their shoulders or their butt or their feet, depending on how they're standing, that is their depth. Okay, so the front to back. So this is an interesting thing that a lot of people don't think about. But when you're looking at something, yes, with your human eye, you can see how things curve. But if you looked at a 3D object from a flat 2D view, okay, a 2D view, so you see this is a 3D cube, but if you're only looking at this front side, it only shows 2 dimensions. That's why it's called 2D, okay? So it shows your height and width on your front. Looking at a person from the front, you'd see their width and their height. Okay, you can't really see their depth. You can't see the back of them. If they turn to the side, however, you see their height and you see that depth, but you no longer see width. If you were above them, looking straight down, you can't see how tall they are, so you can't see their height, but you can see their width and depth. So 2D allows you to only see 2 dimensions. So all 3D objects, individual sides, show 2 measurements because the individual sides are only a 2D view. That is rather confusing. Okay, now to get into this really, you have what's called solid modeling. That's what we are doing in SolidWorks. Imagine that. Okay, now you can do other types of modeling in SolidWorks. You can do what's called wireframe, where it's just the outline. You can do like a see-through, but we mainly do only solid modeling. So when you're doing solid modeling, you have additive or subtractive modeling are the 2 different methods of doing it. Okay, so additive is where you're combining different geometric shapes to an individual component or to make an individual component. So a real world example would be if you take 2 objects and glue them together. Okay, you added them together. Or if you weld them or maybe screw or nail them together or put a bolt through them. That's a real world example. You're adding 2 things together. So say I want to make this object, okay, and I have this object in the classroom made out of foam. So if you wanted to make this, you could do this in several different ways, but here's just a couple examples. So maybe for this approach number 1, you have this piece already, and you have this L-shaped piece already. So that's adding these 2 together to make this, okay? Maybe you just have this big piece with a little square. If you add the 2 together, you still get that. Or maybe you have a whole bunch of individual blocks that you can add together to make that piece. Those are all 100% additive modeling. Okay, additive modeling. Now, what about subtractive modeling? That's kind of doing the exact opposite. So you're removing one or more dimensional geometric shapes from an individual component. So a real world example is if you drill a hole through something, you're actually cutting or removing material away. If you mill it, if you grind it, if you turn it, if you carve it, there's probably some other phrases here that I'm not mentioning, but removing material. Okay, so say we wanted to make this 100% from subtractive modeling. You'd have to start with some sort of rectangle, and maybe it's not in these exact steps, but this is just an example. You would want to subtract this type of shape, okay, from the front side of it. So subtracting that white area, and you'd be left with this. Now, starting with that down here, you'd want to subtract this cube in the corner, and you'd be left with that. Okay, so could you draw this in 3D in this way? Yeah, you could draw a rectangle, extrude it, and then cut all of these individual pieces out. Okay, just like when we did additive, you could draw this piece, extrude it, and then draw this piece and extrude it. You could draw that and extrude it, then draw that and extrude it, or individual blocks. Okay, now those aren't the most efficient ways, but that's what's my job to teach you is the most efficient way. Okay, so it says here on the last slide, combining the methods is probably the most efficient way. Okay, so there is no right or wrong way. If I tell you to draw this object, it takes you 3 hours, it takes me 1 minute, it doesn't matter. As long as it's the exact same object, we're good. Okay, that's the whole point of this. But what I will try to teach you, however, is the most efficient way. So it doesn't take you 2 hours or 3 hours. It takes you the least amount of time to get the correct answer. Okay? So that is computer modeling in a nutshell. So here's another example for you, just step by step. Step one, maybe we draw a small rectangle, extrude it, draw another rectangle, extrude it, draw a small rectangle and cut it away, draw another rectangle and cut it away to get this. Okay, so additive, additive, subtractive, subtractive. So that's just one example of how to do that. Okay, and that is it.